In this video, we will learn how to calculate marginal rate of technical substitution for constant elasticity substitution production function. The question is, given C as production function is the Q is equal to gamma times delta L raised power minus A plus 1 minus delta times K raised power minus A whole raised power minus 1 upon A. We need to find out the marginal rate of technical substitution between labor and capital. Okay, so let me write the production function. So we have output is a function of gamma. Gamma shows us the efficiency parameter times we have delta. I will explain all the terms here in a bit. Then we have L raised power minus A plus 1 minus delta K raised power minus A whole raised power negative 1 upon A. Okay, that shows us that output is a function of labor and capital, which are the two inputs. This gamma shows us what we call the efficiency parameter. It shows us the increase in output that is not being explained by the inputs used in the production process. We also call this solo residual or total factor productivity. Now this delta shows us what we call the distributive parameter. It shows us the share of the labor, and 1 minus delta shows us the share of capital in the total output. This A, what we call alpha actually. So this A is our substitution parameter. Okay, so this is our constant elasticity substitution production function. Now to find out the marginal rate of technical substitution, we know that marginal rate of technical substitution between labor and capital, it is simply the ratio of marginal product of labor upon marginal product of capital. Okay, so first thing is we need to find out marginal product of labor. It is simply, what is marginal product of labor? That is the derivative of partial derivative of production function with respect to labor. Okay, that means we need to differentiate partially this production function with respect to labor. Okay, so let me use the proper color combination here. So what happens if I partially differentiate it with respect to L? So L is here. So first we apply the power function rule. This exponent becomes coefficient. So we have minus 1 upon A. Okay, then we have this gamma. Then we write it as it is. So we have delta. Then L raised power minus A plus 1 minus delta K raised power minus A whole raised power. Now what happens to our exponent? We apply power function rule. Exponent becomes coefficient, and this exponent 1 upon A is subtracted by 1. So we have negative 1 here. Okay, then we apply this chain rule. So first we apply power function rule, then we apply chain rule, that is d upon dl of this this expression which is in the bracket. So I will not have use the color here. So we have delta L raised power minus A plus 1 minus delta K raised power minus A. Okay, so we are applying here power function rule also, and also the chain rule. That gives us marginal product of labor will be equal to so we have negative 1 upon A, then we have this gamma, then we have delta L raised power minus A plus 1 minus delta K raised power minus A times, now we need to differentiate this partially with respect to L. So L is here. What will be the derivative of L here? So the exponent of L becomes coefficient, so we will get here minus A, then we have delta, and the exponent of this will be subtracted by 1. Okay, so since we have L raised power minus A, its derivative will be minus A becomes coefficient and exponent is subtracted by 1. That is what I have done here exactly. and derivative of this will be 0 because we are taking partials with respect to L. This is our marginal product of labor. Likewise, we need to find out the marginal product of capital. So what will be marginal product of capital? So differentiating this with respect to, so we have del Q upon del K this time. So exponent becomes coefficient, so exponent is minus 1 upon A, minus 1 upon A. Then we have gamma, then we have delta L raised power minus A plus 1 minus delta K raised power minus A, and exponent is subtracted by 1, so we have minus 1 upon A, negative 1. Then we take derivative with respect to, and partially differentiate this time with respect to K. Okay, so I cannot write this because I don't have the space here. So if I partially differentiate here, so the derivative of this will be 0, derivative of K raised power minus A will be, so we'll get minus A times 1 minus delta K raised power minus A minus 1. Okay, so here I don't have the space again. So for that, let me do one thing. Let me try to create some space. Okay, I hope I got the space. Now MPL upon MPK, so our marginal rate of technical substitution between labor and capital, which is equal to marginal product of labor upon marginal product of capital, it will be equal to. So here you can see this is our marginal product of labor. So here we have minus A, here we have this A, so this A and this A gets cancelled, minus into minus is plus, so we are left with delta L raised power minus A minus 1. Then we have this gamma, we have gamma times delta L raised power minus A plus 1 minus delta K raised power minus A. This is our MPL. To this we divide by marginal product of capital. Again, this A and this A gets cancelled, minus into minus is plus. We are left with 1 minus delta. Then we have K raised power minus A minus 1. Then we have this thing, that is gamma times del L raised power minus A plus 1 minus delta K raised power minus A. Okay. Okay, here we have minus 1 upon A minus 1. So it will become minus 1 minus A divided by A. This is the exponent, and here we have again minus 1 minus A divided by A. Okay, so here one thing will happen, so gamma gets cancelled, this whole expression gets cancelled. Okay, that gives us marginal rate of substitution. If I write it here, if I have the space, marginal rate of technical substitution between labor and capital, it will be equal to, so we have delta divided by 1 minus delta, 1 minus delta. Okay, now transpose numerator to denominator, denominator to numerator. So we have K raised power this, we transpose it to the numerator, exponent sign will change, we will get K raised power A plus 1. Likewise, if I transpose L to denominator, exponent sign will change, it will become A plus 1. Okay, so we will get marginal rate of technical substitution between labor and capital will be equal to delta divided by 1 minus delta times, since we have the same exponents, we can write K upon L whole raised power 1 plus A. That will be the marginal rate of technical substitution between labor and capital in this case. I hope I make myself clear in this video and you find out these videos helpful. Thank you. So please do subscribe, share and comment so that I can make more useful stuff for you. Thank you.